In this first class of Chapter 5 of this course of Basic Geometry, we present the basic definitions of circumferences and circles, definition of radius and diameter, definition of half circumference and semicircle, definitions of internal and external points to a circumference, perimeter of a circle or length of a circumference, area of a circle, circle sector or circular sector, circular segment of 1 and 2 chords, definition of circular crown, and definition of circular crown sector. In this first slide of this first class of Chapter 5 of this basic geometry course, a circumference is defined as the locus of a set of points that form a curve around a point, with the property of that the distance between the point C, that is the center of each of the points that make up the set, is constant and equal to the radius. The radius is normally named r. This curve is called the circumference. The figure 5.1 shows an example of a circumference. The second part of the slide shows in figure 5.2 a circle, which is the name used to designate the curve of a circumference filled with the internal points forming a disk. Point C is called the center of the circumference and the center of the circle. The figure 5.2 shows an example of a circle. In this second slide is presented the definition of a radius, normally named r, which is the segment of a line r between point C and point A of the circumference and circle. Also show the definition of diameter, which is the segment of a line D between points B and D of the circumference and circle, and has a dimension equal to twice the dimension of the radius. Therefore, the diameter is equal to 2 times the radius. The figure 5.3 shows an example of the two entities, and the second part of its slide is show the definition of a semicircle or half circle, presented at figure 5.4. A diameter BD between 2 points of the curve passes through the center C of the circle or circumference and divides the circumference into 2 semicircumferences, and they also divides the circle into semicircles. This slide presents the definition of internal and external points to a circumference or a circle. Thus, in figure 5.5 is shown a circle with center C and a point A of curve A that has radius r. The points G and E that have a distance smaller than the distance between of the center and the point of the curve are called the internal points of the circumference or circle. The points F and G that have the distance to the center greater than the radius are points external to the circumference or circles, and they are denominated points external to the circumference or circle. In this second part of this slide, it shows the definition of the perimeter of the circumference and the circle. The dimension or length of the circumference or circle, that is, the complete curve of a circumference or circle, is called a perimeter. The value of the perimeter is given by 2 times the value of the constant p, that has the value 3.14159, multiplied by the value of the dimension of the radius. In this new slide, in figure 5.7, a circle of a radius r is shown. The area of the circle is given by the multiplication of the constant p, which has a value of 3.1459, by the value of the dimension of the radius to the square, that is, that multiplies the dimension of the radius by itself. In the second part of this slide, a circular sector is shown in figure 5.8. The circumference comes with 2 points E and F in the curve, where 2 radius are shown. That is, the radius R1 that joins the center C to the point E of the curve, and the radius R2 that connects the center C to the point F of the curve. The area between the two line segments, which form the two radius R1 and R2, and which is known as the curve EF, that is the curve between the 2 points E and F, is called the circular sector of the circle. The total angle of the circle is 2 multiplied by pi radians, or 360 degrees. The area of a circular sector is given by the circle area multiplied by the angle S divided by 360 degrees. This slide shows the concepts of arc, circular segment, sagitta, and chord. Figure 5.9 shows the circle with center C, where 2 points E and F were marked in the curve of the circle. By connecting the point C, which is the center point, to the point E of the curve, we have the radius R1. By connecting point C to point F of the curve, we have radius R2. Thus the central angle S is formed. Drawing the line segment EF is formed a zone between the segment of the line EF and the curve, corresponding to the arc of the circle between the points E and F. This zone is called circular segment, corresponding to the arc EF of the circle. The straight line segment EF is called a chord. If it is traced from the middle of a chord line, a line segment perpendicular until to the curve of the circle, this line is called the sagitta of the circular segment. The area of the circular segment is calculated by subtracting from the area of the circular sector corresponding to the S angle the area value of triangle ECF. This slide shows in figure 5.10 the circular segment of 2 chords. If you are drawn 2 chords parallel one to other, one composed of the line segment E and F, and the other composed of the line segment G and H, the area between the 2 straight line segments and 2 arcs of circumference F, H, and E, G is called the circular segment of 2 chords. The area of a circular segment 2 chords is obtained by subtracting the area of the circular segment generated by the chord EF from the circular segment area generated by chord GH. This slide shows at figure 5.11 the concept of a circular crown. It is drawn 2 circles, one with radius R1 and another with a smaller radius R2. The area between the 2 circles is called the circular crown, circular ring, or annulus. The circular crown, circular ring, or annulus area is obtained by subtracting the area of the circle with radius R2 from the area of the circle with radius R1. The 2 circumferences have the same center C. Thus, these 2 circumferences are concentric. This last slide of this first class of Chapter 5 of the course of Basic Geometry presents the definition of circular crown sector or circular trapezoid. If it is drawn 2 circles, one with radius R1 and one with radius R2 with smaller size, and they are traced 2 radii with a central angle S, then the area between the 2 radii with angle S and also between the 2 circular arcs formed is called circular crown sector, annulus sector, or circular trapezoid. The figure 5.12